Let's do it. All right, so cube root of 250 over 9. Let's just start off with that. Let me get a fresh screen for that one. So here we go. Oops. Oh, here, let me leave it up there. I got to, yeah, I'm having a problem. Sorry. So I would right away take that cube root to the top and the bottom. Take the 250 on the side. Break it down. 25 times 10. 5, 5, 2, 5. So that means that there's, so we have cube root of 2, 5, 5, 5 over cube root of 3, 3. We good so far? I just broke it. Oh, it's showing that thing. Why is it doing that? What is it? What's the problem here? Is it this? And this? No. It's not the Elmo. It's not the laptop. It should be the laptop. Oh, I unplugged it. This is so dumb. Sorry. Maybe I'll do something now. Good. Now let's ship stuff out. So 3 5s inside sends 1 5 outside. So we get a 5 outside. Cube root 2 over cube root 9, 9. Good so far? Is that making sense? Now, we can't leave the root on the bottom. But so notice, I didn't do the bottom first. Everybody take note. I shipped stuff out first. This will make life so much easier for you on the exam Wednesday. Do the ship out first. Now, turn your attention to the bottom. Vincent. Oh, I blew it. It's 2 3s. Thank you. Thank you. 2 3s. Thank you. Now, turn your attention to the denominator. And what do? We want everything shipped out of the bottom. A clean ship out, nothing left over in the root on the bottom, so that the root will vanish from the bottom. That's what they're telling me to do. Get rid of the root from the bottom, right? So he says, give me 3 of anything. That's what that 3 in the hook means. Give me 3 of anything, and I'll ship 1 out. So he's already got 2 3s. How many more do we give him? 1 more 3. So top. You got to do the same thing, top and bottom, keep balance, right? So top and bottom by cube, multiplied by cube root of 3. On the bottom, what are you going to get? 1 plain 3, because 3 3s in, ship 1 3 out. Good? What happens on the top? Just crunch it together. Remember, outside stays outside, insiders with insiders. So the 5 just stays outside. 2 times 3, cube root 6, done. Why can't I cancel the 3 on the bottom into the 6 on the top? Different worlds. Insider, outsider, done. What do we do? Got rid of the root from the bottom. We good there? Questions on that one? All right, I'll move on. Number 2, cube root of 3y to the 4th. So let me write down. So number 2, 3y to the 4th over cube root of 6x to the 4th. Okay, going to do the same thing as last time, right? Breakdown. But actually, let me make a suggestion first up. Could you divide that 3 into 6 right now? Yes. Yeah, do it. Right? They're both insiders. They're both in roots. Great. 3 goes into 6 2 times. Isn't that nice? So if they're both in the same world, you can do it. If they're both insiders, they can cancel like that. So do that, and then go ahead and break down all the y's and the x's and ship out what you can, and then whatever's left over, you're going to have to get rid of the root by multiplying top and bottom. So 4y's on the top, 4x's on the bottom. You know the drill. 3y's in, 1y out, 3x's in, 1x out. So we get y, cube root y over x, cube root 2x. 1x is left inside on the bottom, 1y inside on the top. Good so far? Does that make sense? Now, let me bring it down to here. Y, cube root y over x, cube root 2x. We've got to get rid of that 2 and x from the bottom. right? We don't want any root in the bottom in the end. So this guy's a 3 shipper. 3 in the hook. So he says, give me 3 of everything and I'll ship them out. So he's got a single 2 and a single x. What do we got to give him? 2 more 2's, 2 more x's, right? So multiply by cube root of 2 more 2's, 2 more x's. Whatever you do to the bottom, you have no choice to do the same thing to the top to keep the balance. Is that good? What happens on the bottom? Well, we have the x that's already out front still there. Right? He hasn't gone anywhere. And then the 2x and the 2x, that's another 2x, isn't it? Right? We have 3 2's inside, sends 1 2 out, 3x is inside, 1x out. That's going to end up being 2x squared on the bottom, isn't it? So everybody see what happened there? Am I going too fast? Am I making sense? Not good. All right, and then on the top we have the y that's already out there, and then cube root of 4x squared y. See what happened on the top? 2 times 2 is 4, x squared y. The top just crunches together, right? That's what always happens on the top. Inside stuff with inside stuff. Done. Oh, well, make that 2x squared on the bottom, huh? And then we're done. So y cube root of 4x squared y over 2x squared. Is that good? Can't cancel those x's, can I? Different worlds, so that's it. How are we doing? Anything I can answer on that? Getting all this copied down? Anything? We good? All right. Okay, there you go. Try that one. Same kind of thing. You know, get rid of the root from the bottom. So break down that 28. I like to separate the square root on the top and the bottom. You don't have to. So 2 2's in, 1 2 out, huh? We good to there? So root 3x on the top, 2 root 7 on the bottom. Can't leave a root on the bottom. Finish it from there. 2 7's and I can ship out. So we just need to give him 1 more 7 top and bottom, don't we? And so what do we get? On the bottom we get the 2 that's already out there. And the root 7, plain 7. On the top, root 21x, right? Because 3x multiplies 7. Insiders with insiders. So what does that leave? Root 21x over 14. Done. Are you good at these? Can you do these? This is exactly the way the test will be. This is the hard test, which will separate people. I hope you'll end up on the top heap of that separation. You can, but it's going to take time. You've got to really put time into these. These are hard. It's a harder test. It's a harder material, as you can tell. Is this making sense? Questions I can answer? The average is usually about a grade or more, often 2 grades lower on this exam. I say that to rightly scare you for your good, that you would study harder. This material is just harder. It's just messier. Some people do great on it. I'm sure they put a lot of time in. All right, try that one. Same kind of thing. Got to get rid of roots from the bottom. Remember, what do we got to do on this one? The opposite, called the conjugate. I won't quiz you on the names. But yeah, the opposite. The main thing is remember it's the opposite. How do you know? Like, why on this one? What is it that tells you? Yeah, when you have root and plus or minus in the denominator, multiply by opposite. So, well, let me just say same as denominator, but opposite sign in the middle. Can you read my chicken scratch there? So when you have a square root and a plus or minus, that's the glue, right? Right there, that minus sign is the difference. Everybody see it? Let me show you. Look back at the last problem. See how in the last problem I had, whoops, I'm erasing it. I had 2 root 7, but there was no plus or minus between them, was there? They weren't glued, so I just used the root 7. I didn't need the 2. Everybody see that difference? Everybody see what I'm talking about? Pluses and minuses are Costco glue, aren't they? So back here on number 3, there was just times in the middle there. No big deal. That's just Save Mart. I can buy just one. I just used the root 7. That worked fine. But if that had been 2 plus root 7 or 2 minus root 7 on the bottom, I would have needed to use the whole denominator, opposite sign in the middle. Top and bottom. See the difference? The Costco glue. So here we have a minus sign. So we got to multiply top and bottom by exactly the denominator, opposite sign in the middle, called the conjugate. So there's what you got to do. Now, can you do it? This is not easily done. Try it from there. When you multiply, this minus 16 root 2 is one thing, one term, isn't it? It's not two separate things. So, right, because there's not a plus or minus between them separating them. It's one term. It's going to go boom and boom, isn't it? And when it goes, what's the rule? Outsiders multiply outsiders. Insiders multiply insiders. And then the bottom's a big foil. Out. Let me do that with you. So 16 root 2 multiplies root 5. The inside 2 and 5 multiply root 10, Minus, and then 16 root 6. Good? On the top so far so good? Now on the bottom, it's a foil. They're separate. Even though they're glued, they're still, separate things. It's like Costco, right? They have separate milks glued together. So boom, boom. Now, what's root 5 times root 5? 5. Plain 5. Remember, 2 5s in, 1 5 out. Or square root of 25 if you want, which is plain 5. Plus root 15. He's done. He went to both. Tracking with me? Now, the minus root 3. Boom, boom. Minus root 15 minus plain 3. Root 3, plain 3. And then look what happens in the middle. This is what always happens when you use the opposite, the conjugate, These cancel. That's why we do it. See why we use the opposite sign? Because then we get the plus and the minus and the roots go away. We're trying to get rid of the roots. That's what we need. That's why this works so well. We're doing okay? Everybody see that? Now what's left? Minus 16 root 10. Minus 16 root 6 all over 2, right? 5 minus 3 is just 2. Now, can I do any more? Remember what we've learned. If the 3 outside numbers, him, and him, if they're all divisible by the same number, if the same number goes into all of them, you do it. If one of them can't do it, then you do nothing and you're done. Remember, because they're glued together, aren't there? There's a minus on the top. Those are packaged together. So it's all 3 or nothing. Is there a number that goes into all 3 of them? 2. Divide by 2, negative 8. Divide by 2, negative 8. Divide by 2, 1. So it's negative 8 root 10 minus 8 root 6. We're done. You don't need the 1 on the bottom, right? 1's on the bottom. Dividing by 1 doesn't do anything. There it is. What did we do? We got rid of the root from the bottom. There's no bottom at all. So there's certainly no root in the bottom. All right, I better move on. But practice that. You've got it in your notes, right? That's the kind of thing I would just do over again later. That's how a person learns this challenging stuff, is they try it again later without looking at the notes. If they get stuck, they look at the notes and they try it again later until you can do it without the notes. That takes time. That doesn't come to the casual. It's got to be time. So when you see a problem like this, you know what you want to do? I would put a C next to it for check. These are the kind we were talking about. Any problem that begins with a square root that's an equation. Hey, Wendy. This one's now, what are you telling me? We've been doing roots. The last 4 problems have been roots. Yeah, but they weren't equal signs, right? Look here. See how this has an equal sign, and the next one we'll do, number 6, has an equal sign as well. But there's no equal sign on number 4. There's roots, but there's no equal. It's not an equation. You're not solving. You're just simplifying. Same thing with 1, 2, and 3. Look at 1, 2, and 3. There's no equal sign. There's no equal sign. There's no equal sign, right? So we're talking about when you have a square root with an equal sign, you must check your answer. You're going to get the wrong answer on the test if you don't do that. Because usually one of the answers is removed. And the publisher test answers that I use off the test bank, they always have those other options where they try to fool you. So you've got to remember. So what I would do, here's the kind of thing I did, because I was obsessive. Well, I was a loser when I was in high school. But when I got to junior college, I decided I didn't want to work at Arby's all my life. And so I was going to work hard. And so I was obsessive in junior college. It was my life. And so I would have a game plan, like a sporting event. I would be ready. And so when that exam hit my hand, I would say, I'm going to look through, and every problem with a square root equals, I'm going to write C for check. I would just look through the test real quick. Take you like 10 seconds. And every problem that has a square root with an equal sign, put a C next to it. That way when you get to that, and then go back to number 1 and just start doing the test. When you get to that problem, you'll see your C, and you go, oh yeah, I need to check the answers on this one. You know, do those kind of things. Have those game plans. Be serious about this, if you are serious. That makes sense? All right. And for solving with square roots. So yeah, step number 1, get the root alone. Exactly, add that 3, because you want to get the root alone. And then step 2, parentheses second power, parentheses second power. And step 3, you got to check. Yep. Those are the 3 steps for the square root equal. So yeah, add the 3. And then square root of y plus 6 is 8. So there's step 1. Get that root alone. We did. Step number 2, can you do the parenthesis 2 power, parenthesis 2 power? So parenthesis 2 power, parenthesis 2 power. So the root cancels the square. Remember, they're opposites, so they just eliminate each other. Other side, you actually square the 8 to get 64. So everybody see, why does it actually square on one side, 8 times 8 is 64, but the other side it didn't square the 6 or square the y? Why not? The root canceled it out. That's what happens every time, right? On the side with the root, it just cancels the square and nothing ends up being squared. Just the root and square go away. On the other side, there's no root to cancel the square, so you have to actually square. 8 squared, 64. Last step, subtract the 6. And so y equals that 58? Maybe. So let's check it. So we got to check it. So where do you check it? From the beginning, huh? So square root of y plus 6 minus 3 is 5. Put in the 58. 58 plus 6 minus 3, what is that? Square root of 64 minus 3. So that's 8 minus 3, right? Square root of 64 is 8. 5 equals 5. Yep, it checks. 58 is the real answer. So even if you forgot to check, you'd be okay on this one. It checked out. Good? On that? So the check is just calculator work, isn't it? Just hit the buttons on your calculator to make sure the left side becomes the same as the right side. Our answer is not 5. The 5 equal 5 proves that the real answer, 58, checks out. It makes the two sides the same. It brings balance to the equation, doesn't it? 58 is the real answer.
I still do this kind of stuff in calculus.
Yeah.
You have to check.
Got to check when there's roots involved. Yep. All right. Square root of 2x minus 1 plus 2 equals x. Square root of 2x minus 1 plus 2 equals x. All right. This is going to be a skosh harder. So this would be one of those, you'd put a C over here right away. You're going to check it's a square root with equal sign. As possible. So, okay. So step one, so when you have a root with an equal sign, step one, get the root alone. So subtract that 2, right?
And then you do the square on this side.
So step one, get the root alone. See how he's alone? What's step 2? Parenthesis 2 power, parenthesis 2 power. So parenthesis 2 power, parenthesis 2 power. Rooting cancels squaring. Other side, there's 2 of them. How are we doing? That makes sense? See how on the one side the root canceled the square? So nothing. So I didn't write 2x minus 1s, did I? Why not? Because that root took out that 2. They took each other out. They're both gone. Whereas the other side, there was no root. On the right side, there was no root. So the 2 made 2 of them. I had to write 2 of them, huh? There was no root to take him out. Everybody see that difference on that? And so now, on that right side, you got a FOIL. Minuses, boom, boom. Minus 2x plus 4. Good to there. And so that's 2x minus 1. That's x squared minus 4x plus 4. Right? Minus 2x made minus 4x. Now what do we do? We have an x squared equation. Yeah, what do we always do when we have an x squared? You guys getting more and more comfortable with this? When you have x squared, it's get a 0. So it's a whole new strategy now. When you have x squared, it's all about get a 0 factor with the parentheses, huh? We're in a new zone. Now where do you get the 0? You want to get it on the opposite side from x squared. So make that left side become x squared, 0, huh? So subtract 2x. Oops, So subtract 2x and add 1. Subtract 2x and add 1. Boom, boom. Like that. So 0 minus 6x plus 5. We good? And then, does it factor? I sure hope so. What 2 numbers multiply to be positive 5, add to be negative 1? 5 and 1, both negative, right? Because if you lose $5 and lose $1, you lost 6, and 2 negatives multiply to be positive. And so what are the answers there? Positive 5 or positive 1, maybe. We have to check them. Wouldn't it be a bummer to do all this good work and then not check at the very end and grab the wrong answers? We got to check them. Now, I don't know if they're both going to work or not. We will see. It looks like the 5 works. Oh, the 1 does not. Yeah, usually the lower one is bad. If you're running out of time, cross out the lower one. Now, that's not always. They could switch it up on you. But I'm telling you usually what to expect. Usually the lower number is bad. Now, they could both be good. We've had that a couple times, at least once. They're both good. Sometimes they're both bad and there's no solution. But usually the bigger one's good, the lower one's bad. That's what we have here. Let me show you. So check. X equals 5. So go back to the original equation right here. Root of 2x minus 1 plus 2 equals x. And plug in the 5, right? So that's 2 times 5 minus 1 plus 2 is 5. 9 plus 2 is 5. What's that? 3 plus 2. 5 equals 5. See how it check? Check. So the 5's a keeper. Let's try the other one now, though positive 1 will be no good. So back to the original equation again. And just plug it in, just hit the buttons on your calculator, really, right? Check's easy, just calculate it. Don't need to do any fancy algebra. just calculate. So this will be 2 minus 1, square root of 1, which is 1. 3 equals 1. Nope. So that answer's bad. The only answer is the 5. Be a bummer on the exam to do all that good work. You know the publishers, they'll have like option C, 1 and 5. They'll just have it sitting there for you. They're baiting the hook, trying to catch you like a fish. Don't you bite. You got it. And the way you're going to not bite is by, when you get that exam in your hand, writing the word check. Do you care enough about getting your college degree and getting a job that you enjoy for 40 years to remember on Wednesday to write check next to every question on that exam that has a root and an equal sign? Check them.
This is where you get trust issues.
Trust issues?
Yes.
Because the method is not trustworthy? It's not. It's not.
It's all imaginary.
It's all made up anyway. What are we even doing here? Okay, yeah, 7's pretty hard. I'm going to whip it out because I want to get to other stuff. I want you to have it on the tape, but I'm gonna do it quick. I'm probably not going to give you enough time to do it on your own, probably. The first step, remember the first steps. First off, I should write C over here because this is another one with a square root and an equal, so it looks like there'll probably be 3 on the real exam. So what's the plan when you have a square root with an equal? Step 1, root alone. See the problem? Those 2 roots are together on the same side. One of them's got to be alone, so I'm just going to jump this guy to the other side. And then that gives us root of x plus 2 is 2 minus root 3x plus 4. Why did we do that? Because now on the left side, that root's alone. You might say, yeah, but the one on the right side's not alone. Yeah, it's the best we can do. There's 3 terms, only 2 sides. Not everybody's going to be alone. It's the best we can do. At least we got one of them alone. They want to be alone. Step 1.
Does it matter which one?
It doesn't. You could jump the other one over. Yeah, good question, Vincent. Doesn't matter at all. Step 2, parenthesis 2 power, parenthesis 2 power. So parenthesis 2 power, parenthesis 2 power. So on this side, the root cancels the square. That's always the easy side, right, where the root just takes out the square. On the other side, we always have to write 2 of them, don't we? So 2 minus the root 3x plus 4, 2 minus the root 3x plus 4. Like that. And now we got to FOIL that whole thing out. So here we go. So that 2 is going to go boom and a boom. 4 minus 2 root 3x plus 4, and boom and a boom, minus 2 root 3x plus 4. Am I losing you here? Now, last step. What is negative? Watch this. Negative root 3x plus 4 times negative root 3x plus 4. 2 negatives, positive. Root 3x plus 4 times root 3x plus 4? Plain 3x plus 4. No more root, because that's 2 3x plus 4s under roots. 2 under, 1 out. Huh. Isn't that the rules for roots? For square roots, for 2 roots? See what happened there? See how there were 2 3x plus 4s under roots? And 1 came out when they multiplied. Okay. Now this is a mess. This is probably one of the hardest problems on the test, I believe. So look here, 4 and 4 makes 8. Minus 2 root is minus 4 root of 3x plus 4, plus the 3x, which goes right there. We get to there. Now what? This looks terrible still.
You have to get the root.
Yeah, we have another root. See, this was a double rooter from the beginning. We have this root right here. And what you got to do? You got to get him alone. Whenever you got a root, the plan is to get him alone. So I got to get that root alone. How do I do that? Get rid of everything that's with him. Get rid of the 8. Get rid of the 3x. Get rid of the 3x. Get rid of the 8. boom, boom. So what do we got? What's that? Minus 2x minus 6 equals minus 4 root 3x plus 4. We good there? Yeah, this is a very hard one. Everybody see what happened there? 1x minus 3x made minus 2x, 2 minus 8 made minus 6. So I'm not going to divide off that minus 4 because he's times. You can't add him. I'm just going to leave him. Because if I divided that make fractions, I'm going to leave him. So what do we do now? Parenthesis 2 power. Parenthesis 2 power. Parenthesis 2 power, parenthesis 2 power on both sides. So I need to go to a fresh screen. So remember what's going to happen. On one side, the root and square will cancel. Well, here, let me just write it here. This side, we're going to have 2 of them. Right? Because there's no root to cancel it. So you've got to do 2 of them. On the other side, this 2 squares the minus 4. What's minus 4 squared? Plus 16. But it removes the root when it hits this guy. So it hits both the minus 4 and the root. When it hits the minus 4, there's 2 of them. Minus 4 times minus 4 plus 16. But when it hits the root, it cancels. And it's just 3x plus 4. Not 2 of them, but just regular 3x plus 4. See that? That takes some time and effort to get all that straight. It took time out of my life years ago to get all that straight. All right, so I'll go to a fresh screen. So now you got to FOIL out the left, distribute the right. So we got minus 2x minus 6, minus 2x minus 6, 16, 3x plus 4. 3x plus 4. So boom, boom. So we get 4x squared plus 12x, boom, boom. Plus 12x plus 36, boom, boom. 48x plus 64. We good to there? Gather like terms. 4x squared plus 24x plus 36. 48x plus 64. Now we've got x squared. What do you do when you got x squared? Get a 0. So now we're in x squared with an equal sign. Step 1, get a 0. So to get a 0, I'm going to subtract 48x and 64. So much work, so many places to go wrong. So we get 4x squared minus 24x minus, I think it's 28, isn't it? Yeah. You still with me? Step 2, factor. Now this one, we can take out a GCF first off. What goes in all those numbers? Take out the 4. That'd make life a lot easier. Like that, take out that 4. And then 7 and 1. Sign in the middle goes in the bigger. Minus 7 plus 1. Multiplies to be minus 7. Adds to be minus 6. Right? Okay, now factor, and now each x part equals 0. I don't care about that 4. He doesn't have an x. He can't make anybody 0. He doesn't have a variable. He doesn't have an x. You tracking with me? It's only the parts that have x's that can equal 0. So I just say, and you know it's going to be positive 7 and negative 1, huh? Just opposite, opposite. They're both bad?
No, only one is good.
Yeah, probably the negative 1's bad.
No, negative 1 is good.
Oh, it's a reversal. Ooh. All right, now we got to go check them. So is everybody okay with I threw away the 4 there? Why did I do that? He didn't have an x. It's only the parts that have x's that equal 0. Right? Remember the logic? 4 times something I don't know, because that's an x, times something else I don't know equals 0. What if I told you, real life? 4 times some number is coming out 0. Well, one of those two numbers could be 0. Must be 0. Right? The 4 doesn't have anything to do with it. What if I said 3 times something is 0? Who cares? It just means one of those two numbers is 0 still. The number in the front matters not to the logic. Right? When you multiply things together and it comes out 0, that means any of the parts could be 0 that are unknown. The 4 is not unknown. He doesn't have a variable. He can't vary. He doesn't have an x. He's just 4. He's not going to make anybody 0. But these guys could be 0 because they have an x. They can be different numbers. So those guys are the ones that give us the ability to make these things multiply to be 0. 7, if you put a 7 in here, 7 minus 7 makes it 0. Or -1, -1 plus 1 makes that part 0, doesn't it? All right, so those are my two answers, maybe. Got to check them. This problem never ends. So let's check. X equals 7. Back in the original, root of x plus 2, 3x plus 4. Equals 2. Okay, long problem. Put in the 7. Put in 7. I'm going to skip some steps here. This is going on forever. 20 plus 5 is 25. That's 3 plus 5 is 2. No, that's not true. Yeah, you're right, Claudia. Check the other one. What is it? -1. So much for my rule that the top one's good and the bottom one's. So like I said, it's not always true, and here we go. It's not true here. So 3x plus 4 is 2. Put in the -1. Put in the -1. That'll be root of 1. That'll be root of 1. I'm just cutting steps here. Yeah, that's a yes. So -1 is the only answer. After all that work, it is -1. All right, you see why this test has lower grades than the other 3 exams. What's that? Yeah, some of them are long. Yeah, I think an hour. We're going to have an hour and a half. Yeah, so I think an hour and a half is a reasonable amount of time. Yeah, so. All right, number 8. Guy wire. How long is a guy wire reaching from the top of a 6-foot pole to a point in the ground 4 feet from the pole? Oh, by the way, Rachel's question reminds me. It's a good question. This one was so long. Time test, hour and a half, which I think is a reasonable amount of time. But save the hard ones. Whenever you're in a time pressure test, you want to do you know the strategy is to do the ones that are easy for you first. Come back to the hard ones. Because you don't want to get stuck on something hard, waste a whole bunch of time, and then end up not getting it right anyway, and then you don't have time to do all the ones you would have got right. You know what I mean? So on this test we take Wednesday, go through and do all the ones that are easy for you first. Come back to those, like the double rooter. Don't do that thing till the end. That's super long, and you might not get it anyway. It's super hard. So save it for the end. If you run out of time, it's all right. You know what I mean? So use your time wisely, meaning do all the easy ones first. Save the double rooters and the crazy stuff. All right, so guy wire. How long is a guy wire reaching from the top of a 6-foot pole to a point in the ground 4 feet from the pole? So can you read words like that and draw a picture? That's an important skill on that. So we talk about a wire, and I don't think I drew this very well. Well, it's fine, whatever. So it reaches to a point on the ground. So this is the pole. This is the wire. And it reaches to a point on the ground 4 feet. This is the point. This is the ground down here. It reaches that point on the ground. It's tied 4 feet from the pole on the ground. At a point 4 feet from the pole on the ground. Top of a 6-foot pole. So this is 6 over here, huh? All right. So there we go. They're saying, how long is the wire? So how am I going to find the length of that wire? What's that? Hypotenuse. It's Pythagorean theorem. What's Pythagorean theorem? A squared plus b squared is c squared. Exactly. Which one? Because this is a right angle, right? Assuming that pole's straight up. It's not the leaning pole of Pisa, right? So which one is c? The wire is our c. Remember, the c is always the one alone. So 6 squared plus 4 squared, or you could put the 4 first and then 6. The order on the a and the b doesn't matter. So 36 plus 16 is c squared. What's that? 46, 52. And then want us to root it. So c equals root of 52, that's what? 2 times 26, 2 times 13. So that's 2 root 13. So the exact answer is 2 root 13, right? 2 2's inside, sent 1 2 outside, and the 13 inside stayed inside. And then they want you to use your calculator as well. You get your calculator? What's 2 root 13? 7.2? 1, oh yeah, one's 3 places, huh? 7.211, thank you. You good there? So that one's not bad, right? Do ones like that one. Number 9. Want to try number 9? What are you going to do on number 9? Yeah, when you remember what I is a root. So when you see that I on the bottom, we don't care about the I on the top, but when you see that I on the bottom, you want to think, oh, we can't have an I on the bottom. That's a root. That's a root. You tracking with me on that? So here, I'll rewrite it. Number 7 minus 3i over 5i. Yeah, that I is a root. It's the square root of negative 1. So what? Well, what would you do if you had 5 root 2 down there? Remember, we can never leave roots on the bottom, which means we can never leave i's on the bottom, because an I is a root. So just pretend for a second, because I want to show you in terms of what you already know, so you don't feel like you got to learn something new here. You already know this, right? What would you do if there was a root 2, for example? Yeah, would you multiply by just the root 2, or would you use the 5 as well? Are they glued? They're not glued, right? There's no glue here. No pluses or minuses. So you would use just the root 2, right? Now, if that was 5 plus root 2 or 5 minus, then they'd be glued. We'd have to use the whole thing, opposite sign in the middle, which is the next problem. But on this one, just the root, right? We know that rule, right? Are you good on those differences? When you have when you don't have a plus or minus, they're not glued, and you can use just the root. So in our case, that's actually an I there. So what am I going to multiply top and bottom by? I. Just the I. Don't even need the 5 at all. Why not? It's not glued. Don't need the 5. Keep it simple. Take it from there. Just the I. Now, if that was 5 plus I or 5 minus I, then I would have to use the whole thing, opposite side in the middle, because they'd be glued. Exactly what I do with roots. This is another root problem. Really. Take it from there. What do we have to remember, though? What do we do when I squared shows up? I squared is negative 1. Plain negative 1. Remember how we talked about that? Had a homework section on that. So that's the other thing to remember. So let's do it. So boom, boom. Okay, so we get 7i minus 3i squared on the bottom. Boom. 5i squared. Good so far? And now, this I squared, that I squared, those are negative 1, aren't they? So it becomes 7i minus 3 times negative 1 over 5 times negative 1. Remember, we never leave I squared. I squared is negative 1. We leave plain i's, don't we? We leave plain i's, but we don't leave I squared. So those are negative 1. So what do we get then? 7i plus 3 over negative 5. Now, they want you to separate these. So we'd go 7i over negative 5 plus 3 over negative 5. And they want you to put the real part, the I part at the back. How about saying it that way? Yeah, the I part at the back. So I'm going to go, okay, so it's 3, so it's negative 3 over 5, negative 7/5. See how I put the negatives in the front? It doesn't matter, remember? Negative on a fraction, front, bottom, whatever. But I put the I part in the back, the real part in the front. There we go. What did we do? We got rid of the I from the bottom. Can't have an I in the bottom. An I is a root. Can't have an I in the bottom. Good. Try number 10. Let that copy down. 8i over 7 minus 2i. Okay, try that one. So see how they're glued in the denominator now? So you got to use that whole denominator, opposite sign in the middle, the conjugate, top and bottom. So multiply by 7 plus 2i over 7 minus plus 2i, because that's the glue. Opposite sign in the middle called the conjugate, right? When you've got the plus or minus, that's glue. An I is a root. So here we go. So this is going to go boom, boom. That'll be 56i plus 16i squared. On the bottom, boom, boom. 49 plus 14i, boom, boom. Minus 14i minus 4i squared. So I foiled the bottom there. And these cancel, don't they? See how that's always why we use the opposite sign? And so what do we get then? The top is 56i plus, and then what is, well here, I'll go slow, 16i squared. The bottom, 49 minus 4i squared. And then both those I squareds are negative 1, aren't they? We don't leave I squared, that's negative 1. So we get 56i minus 16 over 49 plus 4. Because the I squared being negative 1 switches the sign on whomever it's with, huh? And so that's going to be, this is what, 53? So 56i over 53 minus 16 over 53. And we got to switch the order, don't we? Yeah. We good to there so far? Last step, we have to put the real part in the front. He takes his baby with him, so minus 16 53rds plus 56 53rds I. Right? Remember, you can reorder things all you want, but you got to take the sign in front of them with them when you move them. So that negative in front of the 16 53rds has to go with them. We good there? There's the answer. All right, I better get to completing the square problems. Okay, so number 12, notice says solve by completing the square. So I'm asking you, this is the only time in the course when I will actually require you to do a problem a certain way and not other ways. It's because completing the square, we could solve that thing with the quadratic formula, really, And that might be a good way to check, but you've got to actually use the completing the square method. I want to see that you know how to do that, because that's valuable if you go on to higher classes after this. My job is to prepare you for those. They do stuff with completing the square that the quad can't do. So anyway, so the way I'm going to do it, the way I'll just, no surprises, this is question 24 and 25. The last two questions on the exam Wednesday, and they're not multiple choice. Because I want to actually see your work. I don't just care about the answer. I want to see your work. I'm going to be judging your work. You can have the right answer, but if you don't have the steps of the quadratic formula, you won't get credit. You have to, completing the square, you have to actually complete the square. So do you know what that means? What does that mean, complete the square? Yeah, exactly. So this will be the last two questions on the exam Wednesday. You got to take, completing the square means take the middle number, put it over 2 squared. I'll write that again. Middle number over 2 squared. Middle number over 2 squared. That's what it means. You got to put the middle number over 2 squared. What is that? Minus 9 squared plus 81. Right? Minus 9 squared. Minus 9 times minus 9 plus 81. And then you've got to, so I've got to see that. I'll be looking to see that you found that number. And then you've got to add that to both sides. So x squared minus 18x is 10. Bring that over. Add 81, add 81. Remember how that works? That's the completing number. That'll complete it. That'll give the left side just what it needs to factor. These three, see how they factor now? See how that makes the 3 on the left? It's perfect. It's just what it needs to factor. What multiplies to be 80? What times what's 81 and adds to be 18? Yeah, 9 and 9, both negative, right? If you lose $9, you lose $9, you lost 18. They multiply to be positive 81. See how it factors to be the exact same thing twice? Perfect. By the way, you don't even have to think that hard. Remember I gave you the rule? The number in the parentheses will be the number in the parentheses every time. Remember that whole process I gave you? That's why I told you to do the 3 steps over here. Write this, divide it, square it. And then the number in the parentheses will be the number in the parentheses. It'll be nice for you. So on the other side, just add them up. Was that 91? So this is x minus 9 squared is 91. How do you finish now? Yeah. Roof on the house. When you put a roof on the house, up and down the ladder. Rooting cancels squaring, so x minus 9 is plus or minus root 91. Bump the 9 over. Becomes a positive 9 plus or minus root 91. There's the 2 answers. 9 plus or minus root 91. It will not be multiple choice. There'll be no options there. You'll have to just do all that yourself and leave that answer.
So we don't need to check those answers?
Don't need to check because the problem didn't start with a root. Yeah, so there's a difference between using a root and a problem beginning with root, right? Their question had no root in it. Don't need to check. Is that good on that? I always get a chunk of people who just leave these 2 blank. They're probably not here today. They just leave them blank. They just look at that. They don't remember what completing the square is. There's no options to guess at. They just leave them blank. 5 points, or 4 points, 4 points. There goes 8 points, almost a grade. Gone. And they wonder why they're not going to get a good grade. You got to learn this stuff. We're not playing games. It's on the curriculum. It's required. You got to learn that stuff. And you can if you give enough time. Wendy's available. I'm available. We're glad to help. YouTube's, it's all out there. But you got to go over it and over and over again. So I'm telling you where it'll be even. No secrets with me. Last 2 problems, 24, 25. Let's do 13 and we'll end. We got to do 13 real quick because that one's just a tad harder than 12 because it has an odd number in the middle. You're going to get fractions. Want to try that one real quick? It's going to be fractions. Let me just rewrite. I don't like t. Let me use an x. So number 13. X squared minus 5x equals 7. Okay, so try that. So take the middle number. Well, I'm going over 2 squared, right? You need to take out of time, so I better dive in there. We're going to get 25 fourths. Positive, huh? Because squared numbers are always positive. So now that means I add that to both sides. So I get x squared minus 5x. So I'm adding 25 fourths to both sides. Now on the left side, it's guaranteed to make it factor. How's it make it factor? Yeah, remember the number in the parentheses is the number in the parentheses. This number right here. Minus 5 halves, minus 5 halves. Right? Those will multiply to be 25 fourths. Remember how that works? Now, how do you do the right side? How do you add 7 and 25 fourths? Over 1. Top and bottom by 4. 28 fourths. Add them up. 53/4. We get to there. See how I added with the common denominator on the right side? Last step. Well, next step, I guess, put the roof on the house. And you put a roof on the house. Up and down the ladder, rooting cancels squaring. X minus 5/2 is plus 1. Now that square root goes to the top and the bottom. And what is the square root of 4 on the bottom?
2.
That's just 2. It'll always do that. And then last step, jump this over. So x equals positive 5/2 plus or minus the square root of 53 all over 2. There it is. We solved for x by the method of completing the square. So you got to show me that method. Now you could check your work with the quadratic formula. That's fine if you wanted, but got to see. I'll look for this little magic number stuff over here on the side. Is that good? That's all the time we have.